Hey guys, today I'm going to teach you how to find the square and square root of numbers. We've in the past done the four basic operations of math: adding, subtracting, multiplying, and dividing, and this is just another type of operation. So by the end of this lesson, you should be able to evaluate the square root of perfect squares. So we're going to figure out what a perfect square is today. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So let's go ahead and get started with what you should already know about squares. This is a square because all of its side lengths are 5. So a square is a rectangular shape where every side length is the same. So every one of these side lengths is 5. So remember what you know about area of a square. It's length times the width. The length is 5 and the width is 5. So the area is always going to be the length times the width. So 5 times 5 for this square. So there's 25 little squares in all. So you probably learned in the 4th grade that you would say the A, or the area equals 25 units squared. And you put a little 2 up there. So that little 2 is going to be what's important today. So that little 2 means that it is squared. And what we're going to be looking at is numbers squared. So instead of drawing the square shape, if I said what is 6 squared, that means I'm going to put a little 2 on it. That means that it is squared. And just think about it like a square. So it's like the same shape that we just drew. The length is going to be 6, the width is going to be 6, and it's like you're finding the area of a square. So you're going to be doing 6 times 6. So this is not 6 times 2. That is 6 squared. So 6 times 6 is 36. So think about it like area. Let me also show you really quickly where this is on your calculator. So this is the squared button. That's going to take it to the power of 2 is another way to say that. So it's an exponent. So these are all three words to say that you want to multiply your number by itself. So it might be a good idea to really quickly just write down these three ways to say that you're going to times a number by itself. So exponent of 2, power of 2, squared. It's this button on the calculator. You could also use this button, and when it pops up, you would type a little 2 in there. So these are all three ways to say that you want to multiply a number by itself. So go ahead and find this page and follow along with me. We're on the square and square roots. Squaring a number, this is the instructions on how to do that. So follow along with me. This will be your directions. It says squaring a number is raising that number to a power of 2. So what we just talked about is squaring means raising it to a power of 2. For example, 4 squared, or 4 to the power of 2, is 16, because 4 times 4 is 16. So think about your square shape that we drew. It's like a 4 by 4. So it is not 4 times 2. The biggest mistake I see people do is think this means 4 times 2. It's not 4 times 2. If it was 4 times 2, they would say 4 times 2. It's a whole different thing. So when it's up in the air, it's a little like a cheerleader has a base and a flyer. It's its little flyer. That means it's going to multiply itself by itself. So it's 4 times 4. When a negative value is squared, be careful to note whether or not the negative sign is inside the parentheses. So pay attention to this. This is really important. So when you're looking at this problem here, there's a negative 2 in parentheses. So this is the same thing, and it just helps to write it out as negative 2 times negative 2. A negative times a negative is always positive. So this would be 4. But be careful, because this one does not have a parentheses. This one right here does not have a parentheses. So if you typed it in the calculator, it would come out negative 4. So go ahead and try this for the next one on your calculator. So go ahead and pull that calculator up and try it with parentheses, then try it without and see what you get. You should realize this is negative 3 times negative 3. That's 9. And then the next one, negative 3 squared without the parentheses, is a negative 9. So the parentheses is very important. It lets you know that it wants the whole thing multiplied by itself. If it doesn't have the parentheses, it's not what it means. So this would be a 16, and this one would be a negative 16. So let's look down just a little bit. Let's just practice our memory of perfect squares, it says. So let's look at perfect squares. So we're going to look at just squares first. So when we square a number, we're multiplying it by itself. So we're just going to go down the line here, and they're going to be called perfect squares. We'll get into why they're called that in just a minute. But what I want you to do is just go through and fill out this chart with all the perfect squares up to 15 squared. So 1 squared is not 1 times 2, it's 1 times 1. So that's 1. Think about it like your doubles. 2 squared is 4, because it's 2 times 2. 3 squared is 9, because it's 3 times 3. So you want to just go ahead and fill out the rest of them, and then come back and check. Okay, I'm going to go through this pretty quickly, because this is just something you can type on your calculator, but this is a really handy list for you to have. These are going to be very important to you. And I know a lot of times when I was in high school, I had to memorize perfect squares. So I had to have all these memorized before I went into the ACT or any sort of test. And they're not hard to memorize because you know 10 times 10 is 100. So all you're doing is just timesing the number by itself. These are called perfect squares. So if you need to take a second, pause and copy that down. Okay, so that was all about squaring a number. Now we're going to do the opposite. So we're going to do the inverse operation. So the opposite of multiply is divide. The opposite of add is subtract. The opposite of squaring a number is to take the square root of a number. So what we're going to write in this first box is that taking the square root is the inverse operation of squaring a number. What's inverse mean? It just means opposite. So let's take a look at what that square root symbol means on your calculator. So the square root symbol looks like this. You might want to practice drawing it. It's got a little hook on it, but it looks like a long division symbol. It's kind of like division, but it's not, because it's not asking if it was the square root of 16. It's not asking you to divide anything. It's saying what times itself equals 16. So it's a special type of operation. So the square root of 16 would be 4, because 4 times 4 is 16. So what you might start to see also is this little symbol, plus or minus. That means it could be a positive 4 or a negative 4, because 4 times 4 is 16, but negative 4 times negative 4 is also 16. So you might also start to see that operation. So be careful with that. Another thing I wanted to show you is that on the calculator, you'll find the square root symbol here. So this is another way to represent the square root symbol. So if you typed in your calculator that button, and then you typed in 25, it would come out 5. So a square root means what times itself gives you that number. So let's go back and look at our notes. It says taking the square root of 16 is both 4 and negative 4, because 4 squared is 16 and negative 4 squared is 16. So look back up here. Negative 4 squared got us 16. 4 squared would also get us 16. So that's why it's got two answers. You'll always have two answers to a square root problem. So the positive square root is known as the principal square root. We probably won't call it that. I just want to make sure you have this down. The positive square root is basically saying 4 is an acceptable answer, but you just want to make sure that you know that both negative 4 and positive 4 could be the solution to the square root of 16. So additionally, 16 is the perfect square. So this is where we got into writing out those perfect squares. So the perfect square means that I can take the square root of it and come out with a whole number. For example, I can't take the square root of 15 because I don't have a number times itself that equals 15. So there's no number that times it by itself to equal 15. I can get the square root of 16 and have it come out to be a whole number, because that comes out to be 4. 4 times 4 is 16. That's what it means by a perfect square. So let's look back down here at the square roots. It's the same thing here in this table that we just did up above. It's just the opposite. So now you're going to go through and just fill out the square root of what number gives you 1. Well, the square root of 1 gives me 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4, and so on. So go ahead and fill that out by yourself and then come back to check. So if you notice, these are the same numbers that we just saw here. So perfect squares are these magic numbers that have an even outcome whenever you put them under the square root symbol. They come out to be whole numbers. So let's take a look at some examples. I want you to try to do these without the calculator, because you should be able to, as long as we always start by writing these out. So for number 1, we have negative 7 with a squared symbol. That means it's going to be times itself. So the first thing I always do is write out negative 7 times negative 7. This is the base. I always want to write the base twice. So negative 7 times negative 7 means that there is a negative times a negative, which is a positive, and then 7 times 7 is 49. So the answer to this problem would be 49. Let's look at number 2. It looks harder because it's a fraction, but it's no different than the last one. So please make sure whenever you see this little squared symbol or any exponent, you go ahead and just take this base number and just write it down twice. 2/3 times 2/3. It's always going to be multiplied by itself. When you multiply fractions, you just multiply straight across. So 2 times 2 is 4, and 3 times 3 is 9. That's it. You're done. So it looks scary because it's a fraction, but all it means is multiply by itself, so just make sure that you're always writing it out. Let's take a look at number 3. It says -9 squared. Here's the catch. There's no parentheses. So thinking about PEMDAS, your exponent comes first. You always have to do your exponent first. So we'll go ahead and take care of 9 times 9, and that's 81. And then there was a negative on the outside, so you'll just bring down that negative. So when there's not a parentheses, remember your answer can be negative. So now let's look at numbers 4 through 6. These are all square root problems. So I'm going to go through them for you. But if you feel like you can try them by yourself, you're welcome to pause at any time and go ahead and then come back and check. But I'm going to go ahead and just go through them with you because they're a little bit tricky. So the first thing I just want to recognize is that this square root of 196, you might not know off the top of your head if you haven't memorized it. So you might want to have that chart that we just made right in front of you because you've already written down the square root of 196. So go back and reference that chart and make sure that you see what the square root of 196 is. You should see that it's 14. So just looking at that chart, you don't even need to use your calculator because 196 is a perfect square. So the square root of 196 is 14. And then if you notice, there's a little negative on the outside. So just bring down that negative. This is your answer. For number 5, you're taking the square root of a decimal. But if you notice, 0.81 looks a lot like 81. And if you look back at your chart, 81 is a perfect square. So without using your calculator, we know that 9 times 9 is 81. So we know there's going to be something to do with a 9. But since there's a decimal, all you're going to do is put a decimal in front of the 9. If you multiply this on your calculator to check, 0.9 times 0.9 is 0.81. And then the last one, number 6, another one that looks tricky. We see fractions and we start panicking. Don't freak out because you see a fraction. These are two perfect squares. So when you see the square root of 9/16, you're just taking the square root of both numbers. So take the square root of 9, which is 3. 3 times 3 is 9. And the square root of 16, what times itself gives you 16? That's 4. And you're done. Just keep it in the same format. If it's a fraction, keep it a fraction, and you're good. That's all you have to do. So what you're going to see in this next section is some operations that go with these. So instead of just finding the square root of 64 for this problem, you're going to find the square root of 64 and then multiply by 2. If there's a 2 on the outside of the parentheses or the square root symbol, you're going to multiply. So for this one, you would take the square root of 64, which is 8, and then just bring down that times 2. So 2 times 8 is 16. So it's a multi-step problem. And these next few problems are multi-step, but I want you to go ahead, pause the video, try all of them. Try all of them. These are on the 8th grade, if not algebra level. So make sure that you can try those first, then press play when you're ready to check. Okay, so by now you should have tried each of these problems, 7 through 12. If you got stuck, that's okay. We're going to go over it. So just pay close attention to when you have a question. So let's start with our PEMDAS. We're going in order of operations. So we look for parentheses, and then exponents and square roots comes next. So we have to do this first before we can add 5. So using your list of perfect squares on the last page, or your calculator, or your knowledge of multiplication, you know that 11 times 11 is 121, and then we bring down this 5 plus. So 5 plus 11 is 16. So that would be counted as the right answer. For anybody who's like just still thinking maybe, well, what did you say about negatives? It could be negative 11, so technically it could be 5 plus negative 11. So there's technically 2 possible answers, but we're just going to assume that it's positive. That's called the principal square root. That's what we just wrote down at the top. But I'm not going to worry about that. So we're just going to stay with 16 for this answer. That'll be fine for now. So now let's look at number 9. So 9 has 2 steps. So we'll take the square root first. We follow our PEMDAS. So we go exponents and square roots first. So the square root of 225 is 15. Then you have a negative 3 on the outside. That means multiply, plus 10. So then we go order of operations. We do multiplication next. So negative 3 times 15 is negative 45. Remember, a positive times a negative is always negative. And then go up 10. So I'm down 45 feet underwater. I go up 10 feet. I am now 35 feet underwater. So negative 35 would be your answer to number 9. Number 10 says find the square root of 144 and then subtract the square root of 36. So the square root of 144 is 12. Take away the square root of 36, which is 6. So 12 minus 6 is 6. So 6 is your final answer. For number 11, it says take 15 times the square root of 16. So the square root of 16 we'll do first. That's 4. And then multiply it by 15. So that'll give us an answer of 60. So 60 is your answer for 11. And then lastly, number 12, take the square root of 81, which is 9, then bring down that negative plus 20. So 20 minus 9 is the same thing as negative 9 plus 20, which gives you 11. So go ahead and try these two questions. This is what we'll start with in class. And then summarize today's lesson with any hints, tips, tricks, anything that you need to remember for the long term that you can look back at and you'll know that you need for this lesson. All right, guys, that's it. If you made it to the end of this video, please put your favorite animal in the comments. Today, we went over squares and square roots. These are just numbers with an exponent of 2, and then square roots are their inverse operation. So now you should be able to evaluate the square root of perfect squares with or without a calculator. So now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.